Talk Evolution, the podcast where real life experiences meets the complexities of today's tech industry. Each episode, we dive into a specific topic with thought leaders who know the systems, the structures, and the nuances of the industry. This series is all about unpacking the inner workings of tech and learning from the people who understand it best. I am Danelle from Evolution Recruitment Solutions, and today I am your host. Today, we're exploring the fascinating world of digital twins and synthetic data, especially how they are redefining robotics and the way we build, test, and scale technology. On this episode, we're delighted to be joined by Daniel Yu, CEO of MetAI, a fast growing deep tech startup based in Taiwan. Under Daniel's leadership, MetAI is pioneering ways to use synthetic data and digital twin simulations to unlock new possibilities in robotics, helping companies design, train, and scale AI systems faster and smarter. Great to have you on the show, Daniel. Before we jump
Hi.
into the big questions, hi, could you tell listeners a little bit about your journey and what inspired you to start Met AI?
Okay, sure. Hi, everyone. I'm Daniel. I'm the co-founder and CEO of MetAI. So yeah, our team has started MetAI 2 years ago, which was early 2023. And I actually have a background that is like so far away from all these robotics, these AI stuffs. I have a finance background. And then when I was working in the finance industry, I came to a conclusion that I really want to create real value to the world, which is why which led me to joining different startups. I joined VR startups, I joined AI startups, and I was more into like a product role that allowed me to start learning how I should build my own product. And then due to the fact that I have a family business, which is in the traditional manufacturing world, I went back to my family business and started to think about how AI can transform, can go through this digital transformation processes for my family business. And I came to realize that lots of people are talking about AI as a plug and play thing, like we just leverage AI and start optimizing our production line or our business miraculously, right? That's what people want. However, AI is never a plug and play thing, and there's this gap which we call an AI adoption gap that basically needs you to fine tune or needs you to come up with other ways to make the AI optimized, right? And that's where my partner Renton, our tech founder, came to me and pitched me with this idea that what if we can build simulation environments to train AI, to gather data from within and then optimize the AI, the industrial or physical AI, even before it touches the real ground. And that is basically what led us to co-founding MetAI with this vision to solve the industrial AI bottleneck before it ever touches the real ground. Yeah,
What an interesting journey. Thanks for sharing the
thank
background. So
you.
let's dive in, yeah? Okay.
Yeah,
So to kick things off, can you break down what digital twins and synthetic data really are, especially in the context of robotics?
yeah, sure. Yeah, so I'll frame this from the lens of what we're building at MetAI, where that will be integrated into robotics and industrial AI. So I think the way we see it, I think digital twins and synthetic data are not necessarily a tool. They're kind of like becoming one of the infrastructure layers for developing AI into the physical world. Because think of it as when we're talking about AI, lots of people will think about ChatGPT, think of a DeepSeek, think about Claude, right? And those are powered by large language models. So they were trained with huge amounts of text, right? But if we're talking about the next wave of intelligence being industrial AI and physical AI, such as robotics, autonomous vehicles, robotic arm, humanoids, and so on and so forth, then it's not like you can train those things with text, right? But what do you need for you to train them into an optimized way? So that basically means that okay, to put it briefly, you basically need to provide worlds for them to understand how how they should operate in the real world. Like what are the physical attributes? What are the operational logic within these environments so that I have all the data that can train these robotics or these industrial and physical AI solutions that can be implemented into the real world, right? That's the whole point. So circling back to your question, I think digital twins are so oftenly misunderstood that digital twins are 3D models. It's not the case here. So 3D model is just like a preliminary part of digital twins. So in practice, digital twins are, think of it as structured as high fidelity virtual environments that exactly mirrors a real world working space. So what matters here is not just the visuals, it's the logic, the behavior, the context that is embedded into this environment So when we think of robotics, for instance, that actually means that a whole warehouse or a whole factory is not just a drawn or a designed environment. It should be simulated down to the physics, the layouts, the constraints, the interactions, the controller logic, the automation stuff that is happening within the real world. So I would regard digital twins as a sandbox where robots and AI agents can train, iterate, and learn within. So once you have that, you have the digital twin, then you are enabled with a possibility that you can generate synthetic data within. So synthetic data is basically computer generated image, for example, images, trajectories, or sensor logic, or even event logs that replicate what you normally have to capture really painfully in the real world. And because it's simulated, right? So you can run thousands, if not hundreds of thousands of versions of a scenario, like different layouts, different lighting, different errors, different edge cases, all without risk or real world cost. That makes you very, very hard to do those, right? So you can create all these types of different synthetic data within a simulated world without real world cost. Yeah.
Okay.
So I think from MetAI's point of view, I think digital twins should not be the end goal. They're kind of like a gateway. So they enable the generation of the right data, the right synthetic data at the right scale to train vision AI, to train robotics, to train multi-agent control systems and simulation policies within these environments that actually can be generalized in a way to do simulations, right? So that's why this digital twin, this synthetic data thing is becoming such a big deal now, because physical AI is no longer kind of like a science fiction. It's like all these robotic companies are coming up with ways to implement physical AI into the real world. Companies are deploying mobile robots. They're deploying smart inspection tools, AI-driven automation in factories, logistics, what we call smart factories, right? And all these things, they need a scalable way to test and train them safely, which is basically in the digital twin, right? Because the real world simply cannot support that kind of speed and iteration or even cost. So that is the gap that we're filling, or we're filling up with digital twins and synthetic data to make it possible to go from blueprints, from layouts into AI training environments, uh, to let physical AI and industrial AI be trained in a simulation environment before it touches the real ground.
I see, I see. Thanks for sharing that. I mean, like you said, it was like very supported and very, I guess, well adopted now with the technology you're using, which is why you guys, of course, are supported by Nvidia. Which brings us to our next question, right? Nvidia has been a big name behind the digital twin movement. How do they view this space, and where does MetAI fit into that bigger picture?
Okay. Yeah, right. I think Nvidia has been very instrumental on in shaping the ecosystem and the simulations and digital twins, right? And so their push on Omniverse, which is their open source platform that people can build simulations on, and even their emphasis on like making OpenUSD, this file format, as the simulation testing bed, the data format, the OpenUSD. All these standards kind of reflects a broader belief, which is simulation will be the foundation for physical AI. Just like LLMs need massive text to train on, building scalable digital twins will be very instrumental for physical AI to scale in the simulation world. But the reality here is that, at least from what we have seen firsthand with the industries at MetAI, I think most enterprises or most corporations, they are not really ready to uh, to to gather or to obtain sim-ready data. By sim-ready, we mean simulation-ready, which is that all those data has all the physical attributes, the operational logic built within these data or these environments, right? So when we think of that, another angle is that for a corporation or for one person to build a sim-ready facility, how much time would that take? Like for a very simple warehouse simulation environment, it will probably take hundreds, if not thousands of hours. But for a corporation to build a very complex factory digital twin, it might take hundreds of thousands of hours. And it's not scalable, right? So we looked at it from a different approach, which is how can we be able to scale digital twins? The process of creating digital twins, the process of creating simulation environments. So we started to think about like all these factories, these warehouses, they draw blueprints when they design when they design the factory, right? So if that's the case, then what if we can supercharge these layouts and then generate a whole sim-ready environment based on the CAD files? So if that's the case, then it will probably be a very great scenario where once you design the factory, it is generated into a simulation-ready environment, right? So we built an proprietary model, which is an algorithm that basically reads all the AutoCAD files, read the CSV files from all the data. We generate the precise digital twin simulation environment for the industry. And I think that is also why we became highly regarded by Nvidia, because if there's an end objective, which is each factory or each production line has their own virtual factory or has their own virtual warehouse, then it's not likely that if all these people need to put in manual works to build all these environments, it's not likely to happen, right? Because it's not scalable. You spend hundreds of thousands on one factory and then another hundred of thousands on another one. So this algorithm became valuable from NVIDIA standpoint, which is if we really can pull this through, then it might be the case that all factories can have their own virtual factory for simulation purposes, for optimization through AI, to implement physical AI into the real world. And I think there's another part which that makes MetAI really different is that we don't really treat synthetic data as an output. We treat it as a product within this infrastructure. Because we believe that the right synthetic data starts from the right digital twin. Because you have the precise enough simulation environment that generates all these synthetic data for you to train your specific purpose AI, agentic AI, or specific purpose physical AI, right? So if that's the case, because we generate these environments so specifically, we would be able to provide realistic synthetic data for real-world training. So I think to wrap it up, MetAI is building a scalable, repeatable engine that can support different verticals on generating precise digital twins and then generating synthetic data that is precise enough for real-world training within. And we're starting from warehouses and advanced manufacturing sites for the industry to leverage simulations to build the real AI in the real world.
I see, I see. And I think we also see a lot of competitors in that space. I think where there is demand, there's competitors, right? And we see people in digital twins, like the big companies like IBM, Microsoft, and in synthetic data, K2View, and things like that. For MetAI, I mean, what is like the unique edge does MetAI bring? Like, especially how you're using synthetic data?
Okay, I think because we're a pure software company, right? So we obviously don't have that much real-world use cases for us to train these models with. But I think one of the advantages that we have is that we are very close with the industry. For example, us being in Taiwan actually gives us it actually creates advantages and disadvantages, right? But it actually creates one of the advantages, which is Taiwan being one of the global epicenters in global manufacturing. It actually allows us to speak very closely with these industry giants so that we understand what they're looking for within these simulation environments. That's one. And the second tier thing is that it actually creates us a possibility where we probably can provide the most down-to-earth synthetic data for these industry giants to leverage upon. So I think being in Taiwan actually creates that much of an advantage so that we can learn from these Taiwanese manufacturing giants and then scale globally, because we have the synthetic data generation, we have the infrastructure that can be scaled outside of these Taiwanese manufacturers. Yeah.
Oh, and then thanks for sharing. On the topic of Taiwan, it brings us to our last question, and that is like being a startup in Taiwan, especially in the deep tech space. What's the talent landscape like there?
Okay, I think Taiwan has a very unique mix on a global standpoint. I think we do have world-class hardware manufacturing, right? And we have so much expertise in mechanical and industrial engineering and more. But I think from a startup standpoint, we're still relatively early. in terms of the startup ecosystem and the deep tech ecosystem, right? And I think that creates for MetAI, I think that's both a challenge and an advantage. And the challenge is that what we're doing, like bridging all these AI with simulations and with real-world automation, I think that is highly interdisciplinary in a way that we're not just looking for AI engineers or technical 3D developers or digital twin engineers. We're looking for people who can work across different boundaries, different verticals, and help us define a new category. By that, the reason for that is because no one has ever came to a conclusion or proven like how digital twins can really help the physical help push through the deployment or the implementation of industrial and physical AI, right? And I think we're kind of cutting edge on this field, which is we're creating this new category within the industry, right? So I think that's not always easy from a Taiwanese standpoint because I think people often specialize deeply in their own field, but we require so much of like going outside of your industry, like to combine your expertise with different types of expertise, right? So that's one of the challenges that we're facing. But I think the flip side is that once people understand what we're building, or once they're really into this, they become so motivated in a way that we regard them as founding members. So I think from MetAI's point of view, we're not like a consulting shop, right? We're not like solving problems for all these industries. We're building we're trying to build a new type of infrastructure for the physical world that enables people to train their AI within simulations before it touches the real ground, right? And that actually excites these builders so much. And these builders are so drawn to becoming a part of MetAI to build something foundational, not incremental. And so that's one advantage that we have. And the other thing that draws talents to MetAI is the ownerships, because we give our team so much of a room to explore and create because we're doing something we regard as new, right? So I think whether some of the talents that previously work in simulation pipelines, some work in 3D generation models, some work with synthetic camera like simulations. So for people at MetAI, they are not just executing a task, they're like designing a system that still has no shape surrounding it. They're trying to build this shape that can define how future AI is trained. And yeah, so I think we're quite lucky to have a team that really believes in this mission, starting from our CTO, my partner Renton, who was an expert in 3D modeling, to engineers that come from all these different industries, including architecture, including these gaming industries, and more. So we built a group that really, at least they thrive on experimentation and systematically thinking. Yeah.
Super interesting you said that. I think because when AI came about, right, we couldn't find someone 10 years ago who was an AI engineer. I think you're in between that situation where your technology is so new, right, that you can't find anyone with the direct experience. Is 3D modeling like the closest you can get to what you're looking out for?
No, not really. So we I think like a lot of people think of 3D modeling as like artists creating these 3D environments, right? But what we do is that we build codes. We develop codes that generate these 3D models. So it's not the same, the exact same as like artistic stuffs that are creating these 3D. Yeah. But I think from a way, I think a difference that we have from 3D modeling is that instead of just creating this 3D model, we're actually creating models that can be simulation ready. So it actually operates exactly the same as, for example, a virtual conveyor belt should move exactly the same way as a real world conveyor belt. And I think that is a gap that should be solved when physical AI takes shape within these simulation environments. Yeah.
Okay, yeah, super interesting. I think it's really great to be in the cutting edge of, I guess, technology, right? Or be in the forefront of a certain technology. So I can see why people are very interested to join MetAI. But yeah, thank you so much for sharing. And that's a wrap for this episode of Let's Talk Evolution. A huge thank you to Daniel Yu for joining us and breaking down what digital twins and synthetic data really means for robotics, and for sharing how MetAI is pushing through the boundaries of what's possible in this space. If you enjoyed this episode, make sure to follow and subscribe so you don't miss out on future conversations with people like Daniel who are shaping the future of tech. Thank you and see you soon.
Thank you, Daniel. Thank you, everyone. Bye.